We're back and we're graphing more vertex form equations. However, today we're going to have to turn them into vertex form. We're going to have to convert them a little bit. So that's where the skill like completing the square comes in handy. We're going to kind of complete the square, but also rearrange some stuff. It's going to get wild. So feel free to pause if this is not already on your sheet and copy that down. I'll get out of the way, pause it. All right, here we go. So we're going to pair up A and B just like we did with completing the square. And we're going to complete the square. But usually when we completed the square, it's like we added 16 to one side of the equal sign and we added 16 to the other to keep it balanced. However, today we're working all on the same side of the equation. So we're going to add 16 over here on the same side of the equal sign. To keep it balanced, we're going to subtract 16 over here because that would net a 0. It would not change the equation at all. But that will allow us to turn it into vertex form. So let's try it. We got 3 examples today. Y equals x squared minus 8x plus 15. So if we were completing the square, usually you would just have the x squared minus 8x together. And let's go ahead and write x squared minus 8x plus blank. We're going to put that in parentheses. Outside we're going to keep the plus 15. But again, to keep it balanced, if I add 31 here and I'm on the same side of the equation, I'd have to subtract 31 somewhere else to keep it even. So we'll say minus blank over here. So here it's plus blank. Here it's going to be minus blank just to even it out. I'll put my equals y. So let's complete that square. Remember, we take b, negative 8, we divide it by 2, and then we square that number. So negative 8 divided by 2 is negative 4, and negative 4 squared is 16. It seems wild to do this, but now if you look, what's in parentheses is one of these perfect square trinomials. This would factor to x minus 4 squared. And then you look back here, we have positive 15 minus 16 is negative 1. That's vertex form now. What? Now if I said, what is the vertex? Remember, that comes from the vertical and horizontal translations. This is going to the right 4. So our vertex would be at positive 4. And then that minus 1 means it's going down 1. So our vertex would be at 4, negative 1. Our axis of symmetry is just the x-coordinate of the vertex. And then we would have to find some more points to finish out the graph. So we have 2 problems that we're going to do like this, where we have to graph it. We have to go all the way with it. And boy, oh boy, that last example is going to be a toughie. Here we go. X squared plus 8x plus 18. So again, we're going to create a little space here. We're going to say y equals, and we're going to put the x squared plus 8x, group that together, and we're also going to say plus blank, because we're going to kind of complete that square. The plus 18 can hang out afterwards, and to cancel out the square over here, we'd have to subtract it on the same side. All right, let's complete that square. We take the 8, divide it by 2, and we'll square it. 8 divided by 2 is 4. 4 squared is 16. So if we just clean that up, the parentheses is x plus 4 squared. And then 18 minus 16 is 2. So here it is in vertex form. Now the vertex, I see x plus 4. That means we're shifting left 4, which means our x-coordinate of the vertex is negative 4. This plus 2 back here means we're going up 2. That means our vertex y-coordinate is going to be 2. So give yourself a vertex at negative 4, 2. Remember, this is also the axis of symmetry. The axis of symmetry would be at negative 4. And if you want to save yourself some work, you can remember the old, once you find the vertex, the steps, it goes up 1 over 1, then it goes up 3 over 1, then it goes up 5 over 1, then 7, then 9, whatever. Now you can scale that. If A is different, this is based off if A is 1, which it is. So from that point, we could just go up 1 over 1 in both directions. Then we could go up 3 over 1 in both directions. Then we could go up 5. That's going to fall off our graph. Yay! Otherwise, to get other points, you can pick other numbers that you want to put in for x, solve it out, and get your y that way. And then you can just reflect them over the axis of symmetry. All right, we got one more. This one is brutal. So tighten your earlobes. Here we go. Oh! 2x squared minus 8x plus 9. I'm going to write that over here. Y equals 2x squared minus 8x plus 9. So we're going to group the a and b together again. All right, we got something to do before I throw in the boxes. If there is a number in front of the x squared, remember that we couldn't do completing the square with that, so we divided everything by 2. Here we're just going to factor out a 2. So we're going to say 2, and that's 2 times x squared minus 2 times 4x. There we go. So now we'll say plus blank. And then we have the plus 9 minus blank. Again, there's still another curveball coming your way on this. So, just like before, we'll take our negative 4 divided by 2 and square it. So that would give us negative 2 squared. Negative 2 squared is positive 4. Cool. So we have y equals 2 parentheses, and it was x minus 2 squared. Oh, here's where I goofed. Oh, I did it. So we put a 4 here, right? When we go back on this, we're going to have to do x minus 2 squared. So we're going to have to do this 4 times the 2, which would give us 8 here. Otherwise, it wouldn't cancel out, because it'd be like we're adding 8 here, but we're only subtracting 4 here. So if you had a number on the outside, when you backtrack and fill out the other square, you got to multiply it by that number out in front. So 9 minus 8 then is 1. That was the other big curveball that we had here. So our vertex, we're going to the right 2. We're going up 1. So our vertex is at 2, 1. The 2 is our axis of symmetry. So let's go ahead and get those first. We have it at 2. Our vertex is at 2, 1. 2, 1. And then usually, if our steps are 1, 3, 5, that's cool, but now we have a 2 out there, so we're multiplying these by 2. So 2, 6, 10. So from our vertex, we can go up 2 over 1. Then we could go up 6 over 1. 1, 2, 3, 4, 5, 6. And then we're good to go. Good to go. Look at us, we're having fun. There it is. The most brutal one we could come up with.